Greetings, programmers! Dan McElroy here with a discussion on C strings with an introduction to pointers. I can't think of a better way to discuss pointers than to use them with C strings. Both C and C++ make extensive use of C strings. A character array is used to store a string of characters with a null byte as a string terminator. A null byte is all bits equal to zeros. The size of the array is the number of characters plus 1 to give room for the null byte. Therefore, the array size is 6 elements, even though there are only 5 characters in the string. Index positions go from 0 to 5. We get 6 elements in the array. Characters are stored in memory as a collection of ones and zeros. The bit pattern for H is 01001000, which is based on the old teletype punched paper tape. Depending on how it's used, the same bit pattern can represent the letter H. It can also represent a decimal value of 72, or it can be expressed as a hexadecimal 48. Here is the ASCII chart. ASCII is a mnemonic for American Standard Code for Information Interchange. The first 32 codes are control codes. Many of them were used when sending data back and forth between computers. Let's look at the chart to see the numeric representation of the letters in hello. Converting the 01001000 bit pattern for the letter H into decimal, we can see that the same bit pattern is used for a decimal value of 72. The bit positions of 64 and 8 each have a 1 in them. When writing code, it is usually more convenient to represent bit patterns in hexadecimal instead of decimal. Each group of 4 bits conveniently represents one hexadecimal character. The bit pattern for 01001000 for the letter H in hexadecimal is 48. In C, C++, and many other languages, the hexadecimal literal of 48 is written as 0x48. Comparing capital letters to lowercase letters, we can see that there is only 1 bit difference between them. This is much easier to see when using hexadecimal instead of decimal. The capital H is 0x48 or 01001000 in binary, and the small h is 01101000 or 68. Now, the big question is, how does the computer know whether the 01001000 is the letter H or the number 72? The computer does not know. It only knows ones and zeros. It's up to the programmer. Unless directed otherwise, the data type is character. A cout statement will display the letter H. If the data type is int, cout will display a 72. As programmers, we can cast the data type to change how the data is displayed. The printf statement has a format specifier string that determines how the data will be displayed. A, quote, %C, quote, in the string will display the value as a character. A %D will display the value as a decimal integer. Here are 4 ways to code an array with a C string. We can use a quoted string. The null terminator byte is automatically placed at the end of the string when the string is defined between double quotes. I don't need to specify the size of the array because the compiler can determine the size from the initialization data. Char message open square brackets equal quote hello quote semicolon. We can also create the string as a collection of individual characters, but we need to make sure that we include the null byte terminator to the end of the string. Each individual character is defined by single quotes around it. Char message open square brackets equals open curly brace single quote H single quote comma single quote E single quote comma single quote L single quote comma. Got the idea? And at the end, there is a single quote \0 single quote to give us the null byte. And finally, a closing curly brace semicolon. We also need to remember that C and C++ use single quotes for a character literal and double quotes for a string literal. You also need to be very careful here. quote 0 quote is not the same as defining the null character single quote backslash 0 single quote. The single quote backslash 0 single quote creates a null byte with all bits zeros. In binary, that is 000000000, but a single quote 0 single quote creates the character 0 from the ASCII chart, not a null byte. The binary code for the character 0 is 00110000. Here is the exact same bit pattern in memory for the string hello, but this time created as a collection of hexadecimal values. Character message array equals open curly brace 0x48, 0x65, 0x6c, 0x6c, 0x6f, 0x00, close curly brace and semicolon. This time, I used a hexadecimal 0x00 for the null byte instead of the single quote backslash 0 single quote. They both do the same thing. Now, let's create the same string using the decimal codes for each character. So, char message array equals open curly brace 72, 101, 108, 108, 111, 0, close curly brace semicolon. This time, I used a decimal 0 for the null byte instead of the backslash 0. They both do the same thing. Here are several ways to output a string to the display. The easiest in C++ is with a cout statement. In C, we can use a printf statement with the %s in the format string. A for loop can also be used to output the characters one at a time. The loop assumes that the size of the string is 5 characters. The 5 is a magic number that shows up in the program just because the original programmer knew the string length was a 5. A better way of coding the program is to have the string length, strlen, function determine the length of the string. For open parentheses, int I equals 0, semicolon, I is less than string length of message, semicolon, I plus plus, close parentheses. That way, if characters are added or deleted, the programmer does not need to go back and count the individual characters to make the updated program work correctly. We can just look for the end of string, EOS, instead of a character count. This way, any length of string can be processed without first needing to know the length of the string. In C and C++, a character can also be treated as an integer. The definition of true is non-zero and false is 0. It is not necessary to test for non-zero, message sub I not equal to 0. Just use message sub I. If message sub I is non-zero, then it is true. If message sub I is 0, then it is false. Every piece of data and every program instruction is stored in memory. Each memory location has an address. Memory addresses are typically expressed in hexadecimal notation. This chart shows how data would look in memory if the string phone home was stored in memory starting at address 7485C. Since a Unicode character uses 2 bytes in memory, the addresses increment by 2 for each character. Hexadecimal 7485C plus 2 equals 7485E. Adding 2 again would represent in 74860. If you are wondering where the first address of 7485C came from, I made it up. The array for character message will be placed somewhere in memory when the program loads and executes. We normally do not need to know the exact memory address of our data, but it is good to have something to work with when discussing pointers. A pointer is a variable that holds a memory address. The data type for a pointer refers to the type of data that the pointer is referring to. A pointer is declared using the asterisk character. Declaring char, star, p-message, semicolon, creates the variable that will hold a memory address, but the variable is not initialized to any specific address. The same type of thing would happen if we declared an integer with int x, semicolon. The value in x has not been initialized and most likely contains some garbage value that cannot be used until x has been initialized with a meaningful value. The name of an array is the address of the array. To set the pointer p-message to the address of the first element in the array, use char star p-message equal message, semicolon. Now, p-message contains the address 7485C. Here are two ways to declare an integer named x, a pointer to the integer, and initialize the pointer to the address of the variable named x. Int x, semicolon, declares an integer and names it x. Int star ptr, semicolon, declares a pointer to an integer and names the pointer ptr. You can give a pointer any valid name. Names of pointers should have something in their name that indicates that they are a pointer. The example on the left uses ptr equals ampersand x, semicolon, to initialize the contents of the pointer to the address of the variable x. You need to be aware that the ampersand also has other meanings in C and C++. It is used as the bitwise AND operator when used between two integers or character values. The double ampersand, 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 is the logical AND operator, and in C++ it is used in function declarations to indicate pass by reference. I hope they don't give it more meanings in the future. The example on the right declares the pointer and initializes it at the same time to the address of the variable x. By definition, the name of an array is the address of the array. For example, if an array is named MSG or message, then just use MSG to get the address of the array, not ampersand MSG, which would cause either a compiler warning or error. That's because ampersand MSG would be like saying the address of MSG. Another way of getting the address of the first element in the MSG array would be to use ampersand MSG sub 0, means the address of the element 0 of the array named MSG. MSG and ampersand MSG sub 0 both refer to the same memory address. We need to keep straight in our minds the difference between the contents of what is in memory and its memory address. MSG sub 0 gives the contents of element 0, which is the letter P. Ampersand MSG sub 0 gives the memory address of the element 0, 7485C in this example. Math operations can be performed on pointers, including incrementing and decrementing. Math operations work by the size of the data. For example, if working with integers, 4 bytes each, adding 1 to a pointer increases the memory address held by the pointer by 4. A character is 2 bytes. If the pointer has a value of 7485C, incrementing the pointer moves the pointer to the address of the next character, 7485E. Character message array equals, quote, phone home, quote, semicolon. Character star P MSG equal message, semicolon. That gives us 7485C. P MSG plus plus, after the increment, P MSG is a 7485E. Again, P MSG plus plus semicolon. Now, after the increment, P MSG is 74860. To dereference a pointer means get the data that is addressed by the pointer. Character message array equals, quote, phone home, quote, semicolon. Character star P MSG equals MSG. Character, first character, just define a character variable here. First character equals star P MSG, semicolon, is the same as first character equal MSG sub 0, semicolon. I personally think it would have been nice to use the @ sign to dereference a pointer. C and C++ never use that symbol for anything, but I'm a user of C and C++ and not its creator. Star MSG and MSG sub 0 both give the contents of the first element, P. Star, open parentheses, MSG plus 1, close parentheses, and MSG sub 1 both give the contents of the second element, H. Watch the order of operation. The asterisk has higher precedence than the plus for addition. Therefore, star MSG plus 1 gives the letter Q, which is the next letter after P. Because star MSG evaluates to a P, then 1 is added to the numeric value for P, which gives Q. In the C language, you can use either pointer notation or array notation when initializing an array with a string. Character MSG array equals quote, phone home, quote, semicolon, does the exact same thing as character star MSG equal, quote, phone home, quote, semicolon. C++ is trying to avoid some types of errors with using pointers. When initializing a pointer with a quoted string, also known as a literal string, the pointer must be declared as a constant, which prevents the programmer from changing the contents of the array. Character MSG array equals, quote, phone home, quote, semicolon, initializes an array the same as const character star MSG equal, quote, phone home, quote, semicolon. When a program is running, the contents of the array can be changed when the array is declared and initialized using the array notation, but not when declared and initialized with the pointer notation. Here is a classic example of how C and C++ can be written using a very few characters in the code. The star PTR inside the while loop causes looping until the null byte is reached. The cout displays the current character, then increments the pointer. This works because the asterisk dereference has a higher priority than the ++ increment. The data from the array is displayed by cout, and the last thing that happens is the pointer is incremented. This technique can also be done in printf. The %C displays the character addressed by PTR, then the pointer is incremented. Here is a comparison between displaying individual characters in the string with a loop. The first example uses array notation. The message sub I in the while statement is looking for a non-zero to keep the loop going. The cout less than MSG sub I++ displays the character located at position I, then increments the index I. The second example uses the pointer notation. The star PTR in the while loop is looking for a non-zero to keep the loop going. Cout less than star PTR++ semicolon displays the contents of the memory addressed by the pointer and then increments the pointer. This is the end, my friend, for discussing C strings and pointers. I hope that you gained a better understanding of C strings and especially a much better working knowledge of pointers. Until next time, bye for now.